Hello, my name is Taylor Sturdevant, and I will be doing my pathogen presentation on Naegleriasis, um, more importantly on Naegleria fowleri. Naegleria fowleri is known as the brain-eating amoeba. It can also be shown in shorthand as N. fowleri. Naegleriasis is a group of amoebas that live in the fresh water. Specifically, N. fowleri is the only brain-eating amoeba in the Naegleriasis group. The basic structure of N. fowleri is it is a protozoa. It is part of the thermophilic amoeboflagellate, also under the pergolozoa. There's three forms of N. fowleri. In the inactive cyst form, you'll see at the bottom right, shown as the little circle. This is how it's stored, and it's resistant to cold temperatures. So this is how it survives when it's not in optimal temperatured water, things like soil and stuff like that. It is inactive. It is not in the reproductive or infection stage. And in the transitionary flagella, this is also a non-pathogenic form. You can see at the middle of the photo, this form has two flagella and is able to move around, not as resistant to cold temperatures, and again, non-pathogenic form. The trophozoites are the form of N. fowleri that becomes a problem. This is the infection and reproductive stage of N. fowleri. This is what's going to infect our host and be able to get in and become the brain-eating amoeba. The trophozoites also is the form that produces the specialized enzymes and toxins that allow for essentially it to eat our brains and become devastating to its host. A couple things it produces. It does produce a protein called NFA1. This is what allows the trophozoite to attach to the target cell. Again, the target cell is going to be brain tissue, brain matter in a human host. It also has cytolytic molecules. There's a few of these that it secretes into its host, and this is what specifically mediates tissue destruction. One of the forms is kind of like a regurgitation on the tissue, the brain tissue, and it actually allows it to physically digest the brain tissue, which is not a good thing. And this is kind of where you're going to get your symptomatic encephalopathy from, and hemorrhaging and brain damage, where again the amoeba physically eats the brain tissue. Transmission is very rare. It is worldwide, so it's not in a specific region, and it doesn't, attack a certain group of people, though young children and males seem to have a higher infection rate of N. fowleri. Most likely that's due to the type of person that's engaging in transmission behavior. N. fowleri is waterborne protozoa. So it lives in fresh water, specifically in 45 degrees Celsius water temperatures. which is warmer. And again, this is the trophozoite that um, thrives in the warm temperatures. In our inactive cyst form, it can thrive in colder temperatures, but again, it's not going to be in its active, infective, and reproductive phase. Some of these areas it can be found is warm water, ponds, rivers, lakes, hot springs. Again, all fresh water. It can be found in some soils. Again, you still have to be at the 45 degrees Celsius. And it actually can be found in some unsanitary swimming areas. This is going to be like warm splash pads, man-made swimming holes, all of which are going to be unchlorinated or not chemically treated to kill specifically N. fowleri. There's other protozoas and stuff. It also can be found in unchlorinated tap water. There has been some infections of individuals using tap water in their neti pots and getting it in their nasal canal, directly in their nasal canal. And that's why it's always recommended to use boiled or saline sterile water. Mode of transportation, it enters through the olfactory nerve in the mucosa. So individuals who are swimming in ponds or hot springs that are getting direct water contact up their nose, the protozoa is able to enter through the olfactory nerve, which is really just direct nasal contact. It will travel from the olfactory nerve to the brain tissue, and it will also live in the cerebral spinal fluid. From here, it is able to attach to brain tissue and will digest tissues and its target cells, again, through the proteins and the molecules that it secretes. And again, this will only be the trophozoite active form, and it will happen only with the presence of this water and amoeba entering through the nose. It's recommended if you're in an area that you're unsure about to use a nasal plug, or if you're in an area of a splash pad, to also use a nasal plug if you're unsure of the chlorination status. Again, though, this is very rare, but it is worldwide. The disease that N. fowleri creates is very deadly, again, though rare. Your early signs and symptoms are going to be flu-like symptoms. You're going to have fever, headache, nausea, vomiting. Late stage is going to cause primary amoebic meningoencephalitis, which is swelling of the brain, cerebral edema, hemorrhagic necrosis, brain herniation, and ultimately death. Incubation period is about 1 to 14 days. Anytime after infection, you can start to see signs and symptoms. The issue with N. fowleri is the early stage symptoms are, because they're flu-like, it's hard to determine what the cause of issue is, or that you even have this amoeba in your system. A lot of times it can show up similar to like a meningitis, and it causes some issues for treatment, for diagnoses. This is what causes the mortality rates, about 98%. Typically when it's found, it's too late. And about average median death onset's about 5 days. So once that amoeba enters your system, starts eating away your brain tissue, it's about 5 days until death occurs. Diagnostic testing is tough with N. fowleri. There's a couple things that can be done to determine if you have the presence of this amoeba in your system. Typically, cerebral spinal fluid samples can be taken. You can do PCR to detect the actual motile amoeba in your system. You can also test for antigen detection. Cerebral spinal fluid samples are not as widely available at all healthcare facilities, which makes it